Hey guys, it's Coach Zane here, and in this video we're going to be talking about the Motors and Movement tab in the EV3 Classroom, Spike Prime and Robot Innovator software. Now, as the name suggests, motors and movements allow the robot to move forward using its wheels and large motors, as well as sideways using turns. We can also use our medium motors to turn attachments. Now, we're going to be doing a bunch of examples today, so make sure you have the programming environment open so we're ready to go. Let's move to the screen. And in this video, we're going to be working on the blue tab and the pink tab. Now, the blue tab called motors, it essentially can only move one motor at a time. So that could be useful for turning with one wheel. It can also be useful for turning one medium motor as an attachment. Now, this purple tab here, that's going to be useful for moving two motors at a time. Now, you can imagine this is quite essential as we need to move the robot forward using its two wheels. It's also useful, as you'll see, for turning on the spot, but we'll get to that later. So let's begin with this blue tab here. Now, let's just try out the first block and I'll go and explain through every single parameter. As you can see, there are 4 parameters we can change. Now, the first one, it has a letter assigned to it. This is essentially the port that you've plugged in your motor into. So I've got mine on port D, so let's go into there. Now, the next one here, it's got a parameter that says clockwise or anti-clockwise. Now, motors spin in a circle, and we can choose the direction of the circle. So by nature, there's only 2 ways that can happen, either clockwise or anti-clockwise, and I'm going to spin mine clockwise. Now, the next 2 parameters, they're quite important. As you can see, we have this one here, and it's followed by a parameter called rotations. Now, we can actually change this to degrees or to seconds. Now, let's explain what rotations is. Essentially, one rotation is one wheel turning 360 degrees. And it's not actually the wheel, it's the motor itself. However, that can be a bit hard to understand as you can't see the motor turn. So we can just understand one rotation as one wheel turning 360 degrees. So essentially, degrees and rotations are in fact the same. One rotation would be the same thing as 360 degrees. Now, we use degrees as it has more precision. So if you were to use rotations, to do 180 degrees, you would have to put 0.5 rotations. It's a lot easier just to type in 180. Not only that, we can type in 183 and we don't have to go to 0.525. So just overall, degrees is a much better option than rotations. Now, you also have seconds, and in general, we want to measure distance and not time. Now, this seconds, it'll change depending on your speed. So that's why it's just a lot easier. Just go for degrees. Now, let's see what happens when we run this program. Okay, so as you can see, the motor moved clockwise. That caused the J on the end to move as well. Now, something that we can't do with this block here is change the speed of the axle turning. So that's why this block isn't very useful. And in fact, if you look at this block followed by this one here, this one simply just starts the motor and moves it clockwise. That's the only thing we can control. So we can't control distance and we can't control speed with this block. So that's not very useful either. Now, this block here, that'll simply stop the motor. This is quite useful, however, you need to get it starting to stop it first. So for our case, not really. You can also set the speed to 75% and then start turning the motor clockwise. So for example, you can set the speed to 75% and then run this block here. So this will set the speed, and now we can change the speed to 50%, and then that axle or that J will turn a little bit slower than it did. Now, instead of this, you can simply just click this block here. As you can see, this now has 5 parameters that we can change. We know we're going to do motor D, and we know we're going to run it for degrees for about 280, just to get the thing to turn all the way. And now we can change the speed of it. So this block contains all 4 parameters, which is why we're going to be using this one mainly. Now let's see what happens when we change this to motor B. Let's run the program. So as you can see, it did a 1-wheel turn. Now instead, if we were to run this one on motor B, so let's click motor B, let's go clockwise, and let's do 280 degrees. This will run automatically at 100% power. Now, in the previous one, as you can see, if I command Z, it ran at 75% power. So this block is more compact and it also contains all 4 parameters that we need, which is why we're going to be using this one mainly and not this one to turn. Now let's finalize and go over the rest of the blocks. So I skipped this one here. Now essentially what this does, it's only got 2 parameters, so you can change the port, which we know what that does. However, you can also set it to hold position or to float. Now hold position essentially means after it's completed its set degrees, it will break automatically. So it'll go to 75% and it'll drop down to 0. Whereas float means it'll essentially coast to a stop, which means it'll turn off the motors. However, there'll still be some residual power and it'll essentially, the friction will stop it as opposed to the robot simply coming to a braking stop. Now, for our cases, we're mainly going to be using hold position as it's more accurate. Okay, now let's see what happens if we want to move the motor the other way. Now, say we want to make a right turn instead of a left turn. How do you do that? Now, we're going to be using this block here, and we're going to set our motor to B. We're going to be doing a negative 360 degree turn. Now the reason why we're going negative is because we want to go the other way. So as you can imagine, if this was a positive, let's change that to degrees. If this was positive, that means the wheel will turn forward. So the robot will turn left. Whereas if you want to make a negative 360 degree turn, it will turn right. You can also change the speed, however, don't change both, otherwise you're just making 2 negatives, which will just make 1 positive. So just to explain that again, if they were both negative, it's as if they were both positive because they would cancel out. So if you do want to make the turn go the other way, just make the degrees negative or the speed negative. They both work the same way. Let's see how that runs. So let's finalize by going over these 3 blocks. Now, A, degrees counted. All this will do is count how many degrees the motor has actually moved. Now this is quite good for checking if the motor has actually moved 360 degrees as opposed to 365. Now, as you can imagine, there'll be an error if you were to go 5 degrees over. And if in an FLL competition, we want to minimize those errors. So this degrees counted is going to be quite essential in our future programs. Now finally, we have these 2 blocks here, which is A, degrees counted. However, it's in a circle. And we also have A, speed. Now we can change those ports to A to D, whichever you want, or whichever ones you're connected to. But what I want you guys to realize is you can't actually connect this one to the start block. Now, we'll talk about this in the future, but essentially Scratch makes you realize if you're making a mistake. So if you're trying to connect a circular block, like this one, to the start tab, it's not going to work. And that's just trying to make you realize that that's something you cannot do. Okay, now let's move to the movement tab. Now, much like the motors tab, there's a lot of blocks here that aren't very essential, but we'll be going over the ones that are. So let's go over first this set movement to B and C. Now, if you have 2 motors you want to move at the same time, you have to let the brick know which 2 you're moving. So I've got my wheels connected to B and C. If you were to perhaps put one to D, all that's going to do is turn 1 wheel and 1 medium motor at the same time, if your medium motor is attached to D. So make sure you set it all to the correct position. Now, we're also going to quickly go over this one here, and as in the motors tab, this is essentially going to control whether it stops, a braking stop, or whether it's going to coast to a stop. Now, as we said, in FLL, we're going to do a hold position where it's going to brake, and that's going to cause less inaccuracies. Now, let's briefly go over what these first few blocks mean. Now, move forward for 1 rotation. Just like the last block, we can move the robot forward and backwards, kind of like clockwise and counterclockwise, and we can move it for however many degrees, rotations, or seconds we want. However, we cannot control the speed in this block. And likewise, in this block here, instead of moving it forward and back, you can control what angle it goes at. So that's essentially, it'll curve. We'll see what that looks like soon. But once again, in this block, you can't see what speed it'll set to. Now, you can use this tab here to set the speed before. However, it's more compact to have a block that does all 4 things at the same time, which is what we have right here. Okay, so let's set our motors to B and C. That's always important. And let's hold our position at our stop. Now, let's move on to the sixth block here. This is going to be the block that allows the robot to move forward or back at a desired speed for a desired amount of distance. So this block contains all 4 parameters. So we're going to want to move straight for 1 rotation, or instead let's do 600 degrees at -40 speed. Now the robot that I've created actually moves forward with negative speed, which might not make sense now. However, all I've done is flip the motors, so when it actually moves forward, the robot's going backwards. That might be a bit confusing. However, in practice, it'll become a lot more clear. So let's see what this block moves like now. Okay, so now let's see what happens if we were to use the 7th block to move forward. So I'll keep this here for now, and I'll use this one. So let's do the same thing, but let's move backwards now. So if we want to move backwards, we'll set this to degrees, and since we moved forward for 600 degrees, we want to move backwards for 600. And let's set the motors to 40 and 40. Now these are essentially the same blocks here. However, this one can let you curve. We'll do an example of that soon, but let's see what this one looks like now. So as you can see, since these were all positive and my robot moves backwards with positive power, it just moved back to its initial position. So all that demonstrated was that these 2 blocks are essentially the same. Okay, now let's see what happens when we want to curve the robot. So in most scenarios, we're just going to want to go straight, and we're going to want to turn to an angle and go straight again. However, there may be certain situations where you want to curve the robot. And to do that, we have this block here. Now we've already discussed this, however, in our previous examples, the straight was set to 0. Now if you want to curve it, just simply set a degree. So I'm going to move my right 20 degrees, and let's do 500 degrees and -40 speed. Now don't get confused with this degree and this degree. So this degree, the right for 20 degrees, is essentially the absolute position of the robot. So if this is my robot here, if I turn it this way, that's now 90 degrees. Whereas this 500 degrees, that's just the wheels turning. So they're 2 separate degrees, but they're both called degrees. Now let's see what this looks like. Okay, now I'm going to demonstrate how to move it back using another block. So we're going to go use this block again. This is the 6th block, that's the 7th block, so now we're going to use the 7th block. And essentially what we're going to do is move it back to its initial position using a curve. Now we're going to set this to 360 degrees and move this at 40 and this one to 20. Now what does this mean? Essentially, this is the motor B power and this is the motor C power. So if one power of the wheel is moving faster than another one, it's essentially going to curve in the position of the faster wheel. So it's practically the same as this one, however we can control the power of the wheels as opposed to just setting a desired angle. So let's see what that looks like now. Okay, now to summarize our 2 blocks that we've discussed, we have the 6th block, which is this one here, and the 7th one, which is this one here. Now, the 6th one, it'll set a target, so if you want to go straight, just set it to 0. It's got an amount of degrees that you want to turn, and you can move both wheels at 1 power. Whereas the 7th block, it's essentially the same thing, however, instead of setting a target angle, you can control the wheel's speed. So, if you want to curve, you can set them to 2 different speeds, whereas if you want to move straight, just set them to the same speed. And just like before, you can set it to 360 degrees or whatever distance you want. Okay, let's now discuss a turn. So, in the previous motors tab, we saw that we can turn the robot by moving one wheel forward and setting the other wheel to brake. And what this caused was the robot to move left or right. Now we can do a turn using our pink blocks as well. The way we're going to do that is by setting one motor to negative. What that's going to do is move one wheel forward and the other wheel backwards, and it's going to cause it to turn on the spot. Now let's change our degrees to 280 because we don't want to overturn. And let's see what that looks like. Now an equivalent turn using our 6th block would be to use this straight, however set that all the way to 100. Now it's going to turn the robot at a certain amount of power for a certain amount of rotations or degrees in one direction. That's going to do the exact same thing. So let's set that to 100 for 280 degrees at 50 speed, and let's see what that looks like. So essentially these two blocks are the same. We call this one here a move tank since you can control the robot's wheels like a tank and it goes forward, and we call this one a move steering since you can control the steering power of it. Now in most scenarios we may use the move tank more often since it's a lot simpler to use and you can physically see the amount of distance you may want to go forward or back at a turn. However, this steering here can be a little bit tricky to use because if you change it from 43 to 44, we can't really see the noticeable difference. Whereas when we control the power with our move tank, we can see that difference. Okay, so using what we've learned, let's now perform an activity. In this activity, we're going to make the robot turn in a square. Now that would include a series of move tanks and turning on the spots. However, before we begin, let's move to the whiteboard and see if we can create a pseudocode just to make our lives easier. Okay, so when you're given an activity or a goal or something that you want to program, an important step is to create a pseudocode. Now, pseudo simply means fake or replica, and code obviously means program. Now, why would we want to create a fake or replica program? One of the reasons to do this is so we can create a pseudocode in our own language. So when we're doing our EV3 classrooms, it's in a language that we don't really understand. It's block by block. Whereas if we were to create a code that had our language, which is English, in pure words and shapes, we would be able to understand and maybe find some interesting things about our program. Okay, so our activity which we want to create a pseudocode for is to make the robot drive in a square. Now a square has 4 sides, so we're going to just begin our pseudocode by creating those 4 sides. So at first we're going to make the robot drive straight. And we don't know the exact distance, so for now we're just going to label that as X. Once we actually jump into the program, we'll know for sure what this X value actually is. After this straight, we're then going to want to do a 90-degree turn. And then that's followed by another straight. One interesting thing you have to note is that this straight is the same distance as this straight, so we can label that as X as well. And that's followed by another 90-degree turn. Now, before we progress, something interesting you want to note is that our program is only 2 blocks. It's just straight here, followed by this 90-degree turn, but it's replicated 4 times. So we actually don't need to do all of this programming. We can just take these 2 blocks and copy paste it when we're in our program. That's one benefit of creating a pseudocode. You can actually understand a few more things to make your life easier when you're creating a code. So let's finish this off. We're going to do another straight. That's X degrees again. And now we want to do another 90-degree turn, followed by our last straight and our final 90-degree turn. And that's it. That's basically our pseudocode. Now, for more complicated activities, as we'll come to in the future, a pseudocode is necessary. For simple things like this, it's not really a necessary step because you could probably go ahead and program it with the knowledge that you have already. Okay, so we've discussed the pseudocode, and now let's see practically what our program would look like. So, as you can imagine, a square first has a side. So, to create that side, let's move the robot straight for a certain amount of degrees. To do that, we'll use this move tank block here. Now, let's move the robot for negative 500 degrees, as we don't want the robot to fall off the table. And let's go at 40 speed for each wheel. If you were to put one wheel higher than the other, then it wouldn't do a perfectly straight movement, it would do a curve, which we don't want since a square has a perfectly straight side. Okay, now we want to turn 90 degrees. So let's pull out another move tank. However, instead of setting both powers at the same amount of degrees, let's do 190 degrees and set this to 50 and this to -50. What that's going to do is make one wheel turn one way and the other will turn the other way. So as we discussed, that's going to be a turn on the spot. You could have also went back to the motors tab and pulled out this one here. And what this would have done, if we set it to B, is moved one wheel only one way. Now the difference between a turn on the spot and a one wheel turn is a turn on the spot is more mobile. It doesn't really change the position of the robot, whereas a one wheel turn would move the robot a little bit to the side as only one wheel is turning. So in practice, we're mostly going to be using a two wheel turn or a turn on the spot. Now we're going to want to go straight again for our square. Now our square has to be perfectly the same length each side, and then we're going to want to do the same 90-degree turn 4 times. So what I'm just going to do is take this and copy paste this 4 times. Now this looks a little bit messy now, but let's neaten it up. So that's our first straight followed by a turn. We want to go straight again followed by another turn, straight again followed by another turn, and then straight for our last side followed by our last turn to bring it to the same position. Let's see what this looks like. So this looks like a quite complex program. However, it's not that hard. In fact, it's mainly 2 blocks here, where in reality it's 10 blocks. So these first 2 blocks, to explain again, we need to set our motors to B and C, and we want them to hold position to stop so it brakes and it doesn't coast to a stop. This will lead to less inaccuracies. We then want to move forward for straight 500 degrees or -500 if your robot moves forward with negative power. And we want to perform a 190-degree turn to turn the robot 90 degrees. Now something important we have to discuss is the difference between this degree, as in the wheel rotation, and the degree of the robot. So 190 degrees is the amount of rotation the wheel needs to turn for the robot to turn 90 degrees. So it might be a little bit easier to think about this degrees as rotation of the wheel as opposed to a degree as an angle. Now to measure this 190, I've just trialed and error. So you can imagine 1000 degrees is definitely not going to be a 90-degree turn. So you can start somewhere about 280 and move your way down until you have that perfect 190-degree turn. We then repeat this 2 blocks over and over 4 times to complete the square, and it's that easy. Okay, so that wraps up the activity of making a square. Now, after you complete an activity, it's important to make observations about how you went. Now, one of the most important things that we saw, and this isn't just for this Motors and Movement tab, it's for all of robotics that you're going to do, is that the program wasn't perfect. So we saw the square wasn't exactly a perfectly straight and 90-degree square. The reason why we knew that was because the robot didn't land in the same position as it started. It was off by a slight angle. The reason for this was because although the first turn was 90 degrees, after that there's a margin of error that's created by the wheel's movement and the slippage of the robot. It could also be due to the weight of the robot. However, there are many reasons why there's error. One of the things we'll learn in the future is how to minimize this error using the use of sensors. Okay, so to recap this video, we learned the motors and movement tabs in the EV3 Classroom software. To do this, we used a bunch of examples. So we turned the motor attachment, we turned the wheel, we used straights to move forward and back, we also covered curves, and we did turns on the spot. Finally, we performed a square using a series of straight move tanks and 90-degree turns using a 2-wheel turn. So that pretty much wraps up this video. Hopefully you enjoyed it, and I'll see you guys in the next one.